What's good, Logan? So coming at you with another video, talking about graphing polynomial functions. If you were aligning this with the assignment, I would say this is probably like assignment 451, 452, somewhere around there. So what we're going to do is we're going to be graphing polynomial functions, which means we also need to understand how to solve them. What I'm going to do is I'm going to do all three of these problems kind of simultaneously and then pull apart like what are the steps that I'm going through each time. All right, so first thing we're going to do is we're going to set them equal to 0. What this does is it finds the x-intercepts. This is the same as if I asked you to solve the polynomial. So we're kind of just saying, okay, so x to the power 4 minus 18x squared plus 81 is equal to 0. So if you have a polynomial equation, kind of like this guy here, x to the power 4 plus x to the power 3 minus 12x squared, if it's not set to 0, then what we're going to do is we're going to get one side equal to 0. Now, since these are functions, we can just say, oh, this is what happens when the y is equal to 0. In other words, when y is 0, that's when we're finding our x-intercepts. So negative 5x to the third plus 40x squared minus 60x is equal to 0. So the first thing I'm going to do is I'm just going to run through these guys, and I'm just going to start factoring like crazy. So like on the first one, you got the x to the power 4, then I'm thinking I need to go x squared times x squared. That's how we get x to the power 4. And then 81, there's tons of possibilities here. 181, 327, 99. I guess there's not a ton. But noticing I need to get the 18 in the middle, I'm going to go with 9 and 9 on this one here. Go double negative here so that when I multiply the negative 9x squared and the negative 9x squared, that's going to end up giving us negative 18x squared. And then I'm going to factor this even further because x squared minus 9, right? So this first one right here is going to factor to x plus 3 and then x minus 3. But since it happens twice, and this kind of makes things nice, is I can write it a second time, x plus 3 times x minus 3. And then I'll combine the factors together. This is going to be a really important idea. You don't have to do this, but it helps us out understanding that a factor is occurring more than once. So x plus 3 squared and then x minus 3 squared. And then now we're going to solve it. So we would go x plus 3 is equal to 0 and x minus 3 is equal to 0. We don't worry to the power of 2. It just means it happens twice. So we have x equals negative 3, subtracting 3 to both sides, and x equals positive 3, adding 3 to both sides. All right, let's try this again on the second polynomial. So I'm going to go ahead and factor this. They have a GCF. So in the g of x question, there's a GCF of x to the power of 2. So I'm going to go ahead and factor out that x squared. And this is going to give us x squared plus x minus 12. And then I'm going to go ahead and factor this guy. You know what? I forgot. It's equal to 0, equal to 0, equal to 0. You're doing the whole zero product property here. All right, back to question number 2. We're going to factor the x squared plus x minus 12 by factoring x squared to x and x. And then 12, we have 1 and 12, 2 and 6, 3 and 4, but 3 and 4 is the one that we're looking for on this one. That way we can get the positive x in the middle, so we're going to go positive 4, negative 3. If factoring is still something that eludes you, come and talk to me. We can talk about this a little bit more, make sense out of it. All right, now we're going to set the factors equal to 0. Now, technically, I don't like using the word technically, but x squared equals 0, you can do that. You could also just say x equals 0 because the exponent only helps indicate that we have multiplicity for these guys here. So x equals 0, and then x minus 3 is equal to 0, and then x plus 4 is equal to, yeah, you got it, 0. So we have x equals 3, we have x equals negative 4, and we have x equals 0. All right, going on to the last one to factor that guy out. It has a GCF of negative 5x, actually just 5x, but I like to have my lead coefficient positive. So if there's a negative in the front, I'm definitely taking that guy out. All right, so we got negative 5x in common, and then we go x squared, sorry for that, minus 8x, and then plus 12 is equal to 0. We're going to go factor that x squared minus 8x to x plus 12 to x minus 6 and x minus 2. Once again, 12 has a ton of options. We talked about on the last problem. On this one, we're going to use the 6 and the 2. All right, and then we're going to solve it. So we're going to say x is equal to 0. Now, if you want to write down 5x equals 0, right, you're like, I want to write that down. You're going to end up dividing both sides by negative 5 anyway, and then it just cancels out. So you could just say x is equal to 0. So we have x is equal to 0, and then we have x minus 6. And if some of you are kind of like looking at this, you're like, I already know that it's x equals 6. I don't have to do the whole as set it equals 0. Awesome. But those of you that are trying to figure out how to solve the problem, like where we're going to get these numbers from, these k values from, you're just setting it to 0, zero product property. All right, next thing I'm going to do. So first step in all three of these problems is I just factored them all out. Now what I'm going to do is I'm going to graph all the x-intercepts. So my first x-intercept I have here is negative 3. So I'm going to go on the x-axis to negative 3. Yay! My second x-intercept is positive 3. So I'm going to go 3 out over here. Yay. All right, going to do the same thing for the next problem, except the next problem we have x equals 0. So I'm going to put the 0 right there. Woohoo! And then we have the 3. So I'm going to go x equals 3, 1, 2, 3. There you are. And then I'm going to go to negative 4, right? X equals negative 4, 1, 2, 3, 4 on the x-axis. So once again, all I'm really doing is just graphing all my x-intercepts. So x equals 0. Woohoo! And then let's go x equals 6. Well, that's way out there, 2, 4, and 6. There you are. And then x is equal to 2. And there we are there. So step 1, factor. Step 2, let's graph your x-intercepts. Now, since we're at the x-intercepts, I want to do one more thing. And this is a little weird. It's not what we normally do. I want to identify if there's any multiplicity, if there's any solutions that repeat themselves. And we can tell is if a factor repeats itself. Some of you might be like, well, what do you mean? So when I take a look at my first problem, notice that this factor repeats itself twice because there's a power of 2 on it. The number of times it repeats itself indicates how it's going to behave as an x-intercept. So on this one, I would identify those as even multiplicity or even repetitiveness. 2, 4, 6, 8, 10. So if it occurs 2 times, power of 2, I would write E. If it occurs 4 times, E. So I'm just looking for repetitions on these things here. So I'm going to highlight that. So for both of them, both this one and this one, they have a repetition that is an even amount, or 2. In this class, we're only going to really focus on the repetition that's twice. I'm not going to look at 3 or 4 or 5 or 6. That is something you will take a look at in pre-calculus, though. If I take a look at the second problem, you'll notice that that factor right there, the x to the power of 2, that has multiplicity of 2. That 0 occurs twice. So I'm going to make sure that I put an E on that guy right there. So I'm going to go ahead and label it as an E over here. I'm going to say, hey, yeah, you're going to be an E. Now I'm doing it with that yellow. It's hard to see sometimes. Sorry about that. It's just because it's not extremely important, but it's good to have. And then when I look at this one, I'm like, oh my God, none of them occur more. So none of those have multiplicity. The other ones are all single. Now, the way that you decide how they're going to behave is that if it has an even multiplicity or even repetition, you're going to not cross the x-axis. You're going to go to the x-axis, you're going to hit the point, but you're not going to cross the x-axis. In other words, you're going to have to bounce off of it. We'll see how that works, excuse me, in just a second. All right, so one more time, let's review. Step 1, we're factoring all these guys out. So we went ahead and we factored them all out like crazy. So we're just factoring everything. Step 2, we're now going to graph all of our x-intercepts. And then step 3, this is kind of an alternate step. Just identify the ones that are occurring an even number of times. Raised to the power of 2 usually dictates that. Raised to the power of 2. All the other ones, they're occurring just once. But when it comes to exponents, we never write the exponent of 1. So you'll never see that. The fourth thing I'm going to want you guys to do, and this is kind of weird, is go back to end behavior. So we take a look at this guy right here. It's an even, so that means it's positive, which means we know the right side is going to be going up. So we know the right side is going to be going up. This one over here, positive, so we know the right side is going to be going up. Right, so we're just taking a look at end behavior right now. Negative, that means we know the right side is going to be going down. So we know the right side is going to be going down. So identify the end behavior on the right side end behavior. If it's positive, it goes up. If it's negative, it goes down. Next, we're going to focus on the left side end behavior. The left side end behavior has to deal with the exponent. So we take a look at this one. It's even, then we're going to match our right side. So the left side, when it's even, the left side will match the right side. So I know my left side is going to go like this. Once again, even, I know my left side is going to match my right side. So I know it's going to be up on that graph. Now, it's odd on the last one, right? It's odd over there. What that tells me is it's not going to match. It's going to go in the opposite direction. So when this guy is odd, the right side went down, tells me that when it's odd, okay? So one more time, let me make sure I understand. You guys understand this. When the coefficient is negative, it's going to go down on the right side. But when it's odd, the left side will not match it. That means the left side is not allowed to go down. The left side must go up. So I know my end behavior on the left side is going to be up because of the the odd exponent on it. All right, so one more time, just going through it real quickly. Step 1, factor these guys like crazy. All right. Step 2, identify your x-intercepts. Step 3, identify the even or the number of times it repeats himself, right? The powers on all of our factors. This is why I will combine the x plus 3 and the x plus 3 as x plus 3 squared. And then the fourth thing is you're going to want to identify your end behavior. All right, fifth thing. So the fifth thing, you're going to want to find your y-intercepts. And this is just a little bit on the helpful side. So now we're going to look at the y-intercepts. y-intercept is the constant term. In this problem, it's 81. So I'm going to go up, we'll call that 20, 40, 60. We're going to call this 81 right here. So 81 right there. I know it's really high up there. This one has no y-intercept, or it's 0, but we already see that right there. So we got the y-intercept of 0, and this one also has a y-intercept of 0, and we see it right there. All right, so the last step, rather than running through all the steps again, is to identify the y-intercept. Now what you want to do is you kind of want to graph it. You're going to want to start with your end behaviors and go to the points towards those end behaviors. Now, if it's an even multiplicity, right, we talked about this here, that's why there's a letter E over there. If it's an even multiplicity, you're going to want to make sure you don't cross the x-axis. So I'm like, oh, look, no, that's bad. It had even multiplicity or even repetition. So I'm going to go towards the even one, and then I'm going to bounce off of it. Now, I'm going to try to make it look as parabolic as possible. Even though it's not a parabola, I'm going to try to make it look like a parabola. And you know what? I don't have to connect it to that guy over there. I just need to make sure my end behavior follows that guy over there. So I'm going to go over there, and then I need to go through this point on the y-axis. And then now on this side, once again, I can't cross it. That would be bad. I have to bounce off of it. I can't cross it because that's what even repetition does. And that's going to be my first graph. All right, let's try it again. So over here, it's going to go through this one. Oh, now, because this one is not even, I can actually go through it. So it occurs just once. I'm allowed to go through it just like that. So we're going to go through it. But I do have to go back up to the E that's over there somehow. So I need to make sure that green dot. So I do need to make sure that I turn the graph around. So I want to turn the graph around, and then that would be wrong. I don't want to go through the E, right? I don't want to go through that green dot. I want to make sure that I bounce off of it. I can't go through it because it had even repetition or even multiplicity. And then this one over here does not have even multiplicity, right? It occurs just once. So we're going to just go right through it like that. So I'm going to go through it, but then I have to go back to that E. So I'm going to go ahead and bounce it back up. Now, I'm not too worried about where it's going to be bouncing like that. I just want to get a gist. I just want to get an idea of where these graphs are occurring. And then, throw some arrows on those guys over there, and our graph is looking solid. All right, moving on to the last problem. So once again, going towards my first point, and I'm crossing it. Going towards my right side point, and I'm crossing it. So starting with our end behavior and going towards our points, and remembering, do we bounce off the point? Do we not go through the x-axis because it's even, or do we go through the x-axis? Then you have to remember that you can't go up forever. You do have to come back around to get to the other x-intercepts. And this guy has to come back around, and then we connect them off. All right, there it is. This is solving and graphing polynomial functions using strictly the factoring techniques. This is, the most primitive, second most primitive. It's not the t-charts, but it's definitely not the most advanced, but it gives you a great idea of what's going on with those x-intercepts. All right, if you guys have any questions, I encourage you to take this thing and slow it down a ton. I'm trying to make the video as short as possible. If you have questions, hit me up by email. Otherwise, I will see you guys in class tomorrow. I'll check you later. Peace.